What you're looking at right now shouldn't exist. According to every law of physics, every cosmic rule we've ever discovered, every model we've built to understand the universe, this galaxy is impossible. And yet, the James Webb Space Telescope found it anyway. 120 million years after the Big Bang, an era when the universe was supposed to be dark, empty, primitive. But instead, Webb captured something that defies explanation, a fully formed, massive galaxy that had no right to be there. Scientists are calling it a crisis, a cosmic anomaly that might force us to rewrite everything we know about the birth of the universe. So what exactly did Webb find, and why are astronomers losing sleep over it? Before we dive into this cosmic mystery, if you're fascinated by the impossible discoveries Webb keeps making, hit that subscribe button. We're exploring the universe's deepest secrets, one mind-bending discovery at a time. Now, let's talk about what makes this galaxy so wrong. See, we have a pretty solid understanding of how galaxies form. After the Big Bang, the universe was hot, dense, and chaotic. It took hundreds of millions of years for the first stars to ignite, then even longer for those stars to gather into the massive spiral galaxies we see today. It's a slow process, like building a skyscraper. You need time, materials, and the right conditions. But this galaxy Webb discovered, it's like finding a fully constructed skyscraper just seconds after laying the foundation. It shouldn't be there. It can't be there. But it is. The galaxy in question has been designated JWST 14-0. Not the catchiest name, but trust me, you'll remember it. Webb spotted it while conducting the JADE survey, the JWST Advanced Deep Extragalactic Survey, which is basically Webb's mission to peer deeper into space and time than any telescope before it. And when I say deeper into time, I mean it literally. Light takes time to travel. So when Webb looks at distant galaxies, it's not seeing them as they are today. It's seeing them as they were billions of years ago. JADE's JWST 14-0 is so far away that its light has been traveling for over 13.5 billion years. That means Webb is seeing this galaxy as it appeared just 290 million years after the Big Bang. To put that in perspective, if the universe's entire 13.8 billion year history were compressed into a single day, Webb is looking at something that existed in the first 30 minutes after midnight. The cosmic dawn, the universe's infancy. And here's where things get weird. According to our models, galaxies this early in the universe should be small, dim, and messy. Baby galaxies, cosmic toddlers still figuring things out. But JADE's JWST 14-0, it's massive, bright, structured. Let me break down exactly why this is breaking physics. This galaxy is estimated to contain hundreds of millions of stars, possibly even a billion. That's an insane amount of mass for something that formed so quickly. Remember, stars don't just pop into existence. They form from collapsing clouds of gas, and that process takes time, millions of years. Then those stars need to come together and organize into a galaxy, more millions of years. But JADE's JWST 14-0 had less than 300 million years to pull this off. It's like expecting a newborn baby to run a marathon. This galaxy is shining with incredible luminosity. That brightness comes from star formation, lots and lots of stars being born. But here's the catch. Early universe conditions were hostile to star formation. There wasn't much heavy elements yet. No carbon, no oxygen, no iron, all the elements that help stars form efficiently. Yet somehow this galaxy is blazing with light, suggesting a massive burst of star formation that shouldn't have been possible. When Webb analyzed the galaxy's structure, they didn't find the chaotic mess they expected. Instead, there are signs of organization, spiral structures, distinct regions, possibly even a supermassive black hole at its center. Supermassive black holes take billions of years to grow. How does one exist when the universe itself is only 290 million years old? It's like finding a fully evolved ecosystem in a tank you filled with water just yesterday. So if this galaxy exists, and our models say it shouldn't, something's wrong. Either our understanding of galaxy formation is incomplete, or the early universe was very different from what we thought. Here are the theories scientists are now scrambling to explore. Theory 1. Dark matter was more active than we thought. Dark matter is the invisible scaffolding of the universe. It creates gravitational wells that attract normal matter and help form galaxies. Maybe in the early universe, dark matter clumped together much faster than our models predict. This could have created pockets where galaxies formed at accelerated speeds. Theory 2. The first stars were monsters. Perhaps the very first generation of stars, called population 3 stars, were far more massive than we imagined, hundreds of times the mass of our Sun. These supermassive stars would have burned hot and fast, pumping out enormous amounts of energy and heavy elements, jump-starting galaxy formation in ways we didn't think possible. Theory 3. Primordial black holes. Some scientists suggest that supermassive black holes didn't grow slowly over billions of years. Instead, they existed from the very beginning. Primordial black holes, born directly from the Big Bang. These black holes could have acted as cosmic seeds, rapidly pulling in gas and stars to build galaxies at impossible speeds. Theory 4. We're wrong about the Big Bang timeline. This is the most radical possibility. What if our entire timeline of the universe is off? What if the Big Bang happened differently than we think, allowing more time for these structures to form? It's a long shot, but JWST Z14-0 is making astronomers consider it. Here's what makes this even more unsettling. JWST Z14-0 isn't alone. Webb has found multiple impossibly early galaxies, each one massive, bright, and structured in ways that shouldn't be possible. There's CEER S93316, another ancient giant spotted just 235 million years after the Big Bang. There's HD1, which might be even older, possibly the most distant galaxy ever detected. And with every new observation, Webb keeps finding more. It's not an anomaly, it's a pattern. The early universe was far more active, far more violent, and far more productive than we ever imagined. Galaxies weren't forming slowly and carefully, they were exploding into existence with shocking speed. One astronomer described it as cosmic archaeology, finding cities where we expected to find caves. And that changes everything. So where do we go from here? Webb is just getting started. Over the next decade, it will continue scanning the deepest reaches of space, looking for more impossible galaxies, more cosmic rule breakers. Astronomers are now racing to update their models. New simulations are being run, new theories tested. The textbooks are being rewritten in real time. Because here's the thing about science. It's not about being right. It's about being willing to be wrong. For decades, we built a beautiful, elegant model of how galaxies form. It made sense. It fit the data we had. But now we have better data, and that data is saying, you missed something big. JADE's GS-Z140 is a reminder that the universe is under no obligation to make sense to us. It existed billions of years before we did, and it will continue long after we're gone. All we can do is look up, keep asking questions, and stay humble in the face of cosmic mysteries we're only beginning to understand.
So that's the galaxy that shouldn't exist, but does anyway. A cosmic impossibility rewriting everything we thought we knew. What do you think is happening out there? Are our models wrong, or is something even stranger going on? Let me know in the comments. If you want more mind-bending discoveries from the James Webb Space Telescope, subscribe and turn on notifications. We're diving into the universe's deepest secrets every week. And if you made it this far, here's one last question. If we can barely understand what happened 290 million years after the Big Bang, what else are we missing? Thanks for watching. Keep looking up.